Assalamu alaikum dear students. Hope you are all right by the grace of God. Today the topic we are going to discuss is the simple pendulum, and it is one of the most important topics of this chapter and also from the paper's point of view. So simple pendulum is just a small mass, or we can say it's a bob, which is suspended by a weightless and inextensible string from a fixed frictionless support. From the diagram given, you can see that we have attached a bob with a string, and in turn the string is attached to a fixed support. Okay, this is the mean equilibrium position. This is the rest position of the bob when there is no force applied to the bob. Right now, when there is no net force acting on it, the only two forces are this weight and the tension in the string. These two forces balance the bob, and there is no resultant motion of the pendulum. Okay, you can see when the pendulum is at rest, the two forces acting on it are just weight and tension. Then these forces balance each other. Now, what happens when we displace this pendulum by a certain distance x? We call it x. Okay, what will happen? We will provide it enough energy to stay in a higher amplitude. Okay, so now what are the forces acting on the bob at point A? The two forces are again the tension in the string and the downward weight. But here you can see that the weight is not really vertical. It has a vertical component and a horizontal component. You can see. But don't get confused with like this is the vertical component and this is the horizontal component. These are not so. This will be the horizontal component, okay, because this is the weight and this is where we need to find the acceleration. Okay, this will be the base and this will be the perpendicular. Okay, so for the base we will have W parallel to the string equals to mg cos of theta, and W perpendicular equals to, definitely you know that, it becomes mg sine of theta. What happens now is that three forces, actually two, but three components of forces are acting on it. The weights, the parallel weight mg cos of theta, and the perpendicular weight mg sine of theta, and the tension, of course. The tension and the parallel weight balance each other. Here you can see the parallel weight and the tension balances each other, while the W perpendicular causes acceleration. Here you can see that W perpendicular is directed towards the mean point. So what will it do? It will cause the bob to start motion in the direction of mean position. Okay, so it will start its motion towards the mean position. Right now, at extreme position, the potential energy is maximum and kinetic energy is zero. Potential energy is maximum because at point A the bob is at the maximum height, and kinetic energy is zero because there is no motion at all. As there is no motion at all, so there is no kinetic energy right now. But what happens when we release the bob? When we release the bob, it will start its journey towards the mean position and at point O. What are the forces at point O? The forces will be just like the weight was in the rest case. The tension and the weight. Tension and weight balance each other, The bob continues its motion due to inertia. Remember that the bob won't stop its motion at the mean position now. Because of inertia, it will travel to the next extreme position, which we call the A prime. Okay? And the kinetic energy will be maximum and potential energy will be zero at the mean position, because there won't be any height, so the potential energy will be zero, and there will be maximum velocity, due to which the kinetic energy will be maximum. Okay, after reaching the point A, the same thing would happen as in the case of A. At A point, at A prime, the bob again starts its motion to the mean position due to the vertical component of the weight, or the perpendicular component of the weight. Okay, so in this case, when we displace it through some distance, it will start moving to and fro about the same mean position. Okay, now what will be the time period? The time period is given by t equals to 2 pi under the root L over g. It is very important and it's very necessary to note that the time period of a simple pendulum does not depend on mass. It does not matter if you just attach a rubber ball of mass 20 gram or a steel ball of mass 200 kg. It will oscillate with the same time period, provided that the length in both cases is the same. So it just depends upon the length of the string. Okay, another point is that the acceleration produced in the simple pendulum will be directed towards the displacement. It will be directly proportional to the displacement, but we don't get confused with the negative sign. It just shows that it is directed towards the mean position and not in the direction of the applied force. The negative sign determines the direction of acceleration. X determines that with the increase of x, the acceleration will also increase. So this was all we needed to know about the simple pendulum. Okay, I will share some of the questions related to it, and you will have to solve it, and you will have to submit your questions, your assignment, your homework till tomorrow by 2 p.m. Good day, dear students.